What you need to know about Zener diode. A Zener diode is a special type of semiconductor diode designed to allow current to flow in the reverse direction when the voltage is above a certain value known as the breakdown voltage or Zener voltage. Here is a comprehensive overview of Zener diodes. Basic principles of Zener diodes. Zener diodes are semiconductor devices specifically designed to operate in the reverse breakdown region. Unlike standard diodes, which are damaged if they exceed their breakdown voltage, Zener diodes are designed to exploit this phenomenon safely. Here are the basic principles. 1. Operation. Forward bias. Like regular diodes, Zener diodes allow current to pass in the forward direction, anode to cathode, when the forward voltage exceeds the threshold, typically 0.7 V for silicon diodes. Reverse bias. When a reverse voltage is applied, a standard diode blocks current flow. However, if the reverse voltage exceeds a certain value, the Zener voltage, the Zener diode begins to conduct in reverse. This reverse conduction is controlled and non-destructive, unlike in a regular diode. 2. Zener voltage, VZ. Definition. The Zener voltage is the reverse voltage at which the diode begins to conduct significantly in the reverse direction. This voltage is determined during the manufacturing process and is a key specification for Zener diodes. Range. Zener diodes are available with Zener voltages ranging from a few volts to several hundred volts, making them suitable for various applications. 3. Breakdown mechanisms. There are two primary mechanisms by which Zener diodes achieve breakdown. Zener breakdown occurs at low Zener voltages, typically below 5 V. Involves quantum mechanical tunneling, where electrons tunnel through a narrow depletion region, characterized by a sharp and well-defined breakdown voltage. Avalanche breakdown occurs at higher Zener voltages, typically above 5 V. Involves the impact ionization process, where high-energy electrons collide with atoms, creating more free electrons and holes. Leads to a more gradual increase in current with voltage, but still maintains a stable Zener voltage. 4. Voltage regulation. Stabilization. Zener diodes are widely used for voltage regulation because they maintain a nearly constant output voltage despite changes in the input voltage or load conditions. Series resistor. To operate a Zener diode as a voltage regulator, a series resistor is typically used. This resistor limits the current through the Zener diode, ensuring it operates within its safe region. 5. Current voltage, IV, characteristics. Forward characteristics. Similar to a regular diode, the Zener diode allows current flow when the forward voltage exceeds the threshold. Reverse characteristics. When reverse biased, the current remains minimal until the Zener voltage is reached. At the Zener voltage, the diode conducts heavily, maintaining a stable voltage across its terminals. 6. Power dissipation. Heat management. Zener diodes dissipate power when conducting in reverse, which can lead to heating. The power dissipation ratings. Zener diodes are rated for maximum power dissipation, which should not be exceeded to prevent damage. Example of a simple Zener diode circuit. Suppose you need to design a voltage regulator to provide a 5 V output from a 12 V power supply. Select a Zener diode. Choose a Zener diode with a Zener voltage. Summary. Zener diodes are crucial components in electronic circuits for voltage regulation and protection. Their ability to maintain a stable voltage in the reverse breakdown region makes them indispensable in various applications, from power supplies to protection circuits. Understanding their basic principles helps in designing effective and reliable electronic systems. Characteristics of Zener diodes. Zener diodes are designed to operate in the reverse breakdown region, where they maintain a stable voltage across their terminals. Here are the key characteristics that define their behavior and applications. 1. Zener voltage, VZ. Definition. The Zener voltage is the specific reverse voltage at which the Zener diode starts to conduct significantly in the reverse direction. Range. Zener diodes are available with Zener voltages ranging from a few volts to several hundred volts. Tolerance. Zener voltage tolerance indicates how close the actual Zener voltage is to the nominal value, often specified as a percentage. 2. Reverse current is breakdown current. When the reverse voltage applied to the Zener diode reaches the Zener voltage, the diode conducts a significant current in the reverse direction, known as the Zener current, is. Minimum current is the minimum current required to maintain the Zener voltage. Below this current, the voltage may not be stable. Maximum current is the maximum current the Zener diode can handle without being damaged. This is often specified along with the power dissipation rating. 3. Power dissipation, PZ. Power rating. Zener diodes are rated for maximum power dissipation, typically ranging from a few milliwatts to several watts. Calculation. Power dissipation can be calculated using the exceeding the power rating can overheat and damage the diode. 4. Dynamic impedance, ZZ. Definition. Dynamic impedance is the small signal AC resistance of the Zener diode in the breakdown region. Impact. Lower dynamic impedance means better voltage regulation. It is defined as are small changes in voltage and current, respectively. 5. Temperature coefficient. Effective temperature. The Zener voltage changes with temperature. This change is expressed as the temperature coefficient, usually in ppm/degree C or mV/degree C. Positive/negative coefficient. Zener diodes with a Zener voltage below 5.6 V typically have a negative temperature coefficient, while those above 5.6 V have a positive temperature coefficient. Diodes around 5.6 V can have a near zero temperature coefficient. 6. Current voltage, IV. Characteristics. Forward characteristics. In the forward direction, Zener diodes behave like regular diodes with a forward voltage drop of about 0.7 V for silicon diodes. Reverse characteristics. In the reverse direction, the current remains very low until the Zener voltage is reached, at which point the current increases rapidly, maintaining a nearly constant voltage. 7. Breakdown voltage tolerance. Manufacturing variations. The Zener voltage can vary slightly due to manufacturing processes, which is why Zener diodes come with a specified tolerance, typically plus or minus 5% or plus or minus 10%. 8. Breakdown mechanisms. Zener breakdown dominates at lower voltages, below approximately 5 V, due to quantum mechanical tunneling. Avalanche breakdown dominates at higher voltages due to impact ionization. Applications. Voltage regulation. Zener diodes are widely used in power supply circuits to provide a stable reference voltage. Over-voltage protection. They protect sensitive electronic components from voltage spikes by clamping the voltage to a safe level. Waveform clipping. In signal processing, Zener diodes can clip the peaks of waveforms to create a desired voltage range. Voltage shifting. They can be used to shift voltage levels in logic circuits. Practical considerations. Heat dissipation. Ensure that the Zener diode's power dissipation does not exceed its rated value to prevent overheating. Series resistor. A series resistor is typically used to limit the current through the Zener diode, ensuring it operates within its specified range. Circuit design. Careful selection of the Zener diode and series resistor values is crucial for effective voltage regulation. Example calculation. For a circuit requiring a stable 5 V output with an input voltage of 12 V, choose a Zener diode. Select a Zener diode with. Choose a standard resistor value close to 280 ohms, such as 270 ohms or 300 ohms. Summary. Understanding the characteristics of Zener diodes is essential for their effective application in electronic circuits. They offer reliable voltage regulation and protection in various configurations, making them indispensable components in modern electronics. Applications of Zener diodes. Zener diodes are versatile components used in various applications, primarily for their ability to maintain a stable voltage under reverse bias conditions. Here are some common and practical applications. 1. Voltage regulation. Power supplies. Zener diodes are used to provide a stable reference voltage in power supply circuits. They maintain a constant output voltage despite variations in the input voltage or load conditions. Series regulator. In a simple Zener diode voltage regulator circuit, a series resistor is used with the Zener diode to drop the excess input voltage and maintain a constant output voltage. 2. Over-voltage protection. Clamping diode. Zener diodes can protect sensitive electronic components from voltage spikes by clamping the voltage to a safe level. When the voltage exceeds the Zener voltage, the diode conducts and prevents further increase. Transient voltage suppression. TVS Zener diodes are used in TVS devices to protect circuits from transient voltage spikes, such as those caused by lightning or electrostatic discharge, ESD. 3. Waveform clipping. Signal processing. Zener diodes are used to clip the peaks of AC waveforms, limiting the voltage to a specific range. This is useful in audio processing and communication systems to prevent signal distortion. Dual clipping. Using two Zener diodes back-to-back in opposite polarity can clip both the positive and negative peaks of a waveform. 4. Voltage shifting. Level shifting. Zener diodes can shift voltage levels in logic circuits, allowing compatibility between different logic families or interfacing different voltage levels. Biasing circuits. They are used in biasing circuits to set a specific voltage level, often in amplifier or comparator circuits. 5. Reference voltage. Precision reference. Zener diodes provide a stable reference voltage for analog-to-digital converters, ADCs, digital-to-analog converters, DACs, and other precision measurement devices. Temperature compensation. In circuits requiring temperature-stable reference voltages, Zener diodes with specific temperature coefficients are chosen to compensate for temperature variations. 6. Switching applications. Zener as a switch. Zener diodes can be used in switching applications where a circuit needs to be activated when a specific voltage is reached. The Zener diode will conduct and trigger the switching mechanism once the Zener voltage is exceeded. Practical circuit examples. 1. Zener voltage regulator. Components. Zener diode, VZ equals 5.6 V. Series resistor, R. Input voltage, VIN equals 12 V. Load resistor, RL. Circuit description. The series resistor, R, limits the current through the Zener diode. The Zener diode maintains a constant 5.6 V across the load resistor. 2. Overvoltage protection circuit. Components. Zener diode, VZ equals 12 V. Load device, e.g., microcontroller. Circuit description. The Zener diode is connected in parallel with the load device. If the input voltage exceeds 12 V, the Zener diode conducts and clamps the voltage, protecting the load device. 3. Signal clipping circuit. Components. Two Zener diodes, VZ equals 5.1 V. AC signal source. Circuit description. Two Zener diodes are connected in series, but in opposite polarity across the signal source. The diodes clip the positive and negative peaks of the AC signal to plus or minus 5.1 V. Summary. Zener diodes are crucial in a wide range of applications due to their ability to maintain a stable voltage and protect circuits from overvoltage conditions. Their versatility makes them indispensable in power supplies, protection circuits, signal processing, and precision reference applications. Understanding how to utilize Zener diodes effectively can significantly enhance the reliability and performance of electronic circuits. Circuit design with Zener diodes. Designing circuits with Zener diodes involves understanding their characteristics and applying them to achieve specific functions such as voltage regulation, overvoltage protection, and signal clipping. Here are some detailed examples of circuit designs utilizing Zener diodes. 1. Zener voltage regulator. A Zener voltage regulator is used to provide a stable output voltage. Here's a step-by-step guide to designing a simple Zener voltage regulator circuit. Components. Zener diode, VZ. Series resistor, R. Input voltage source, VIN. Load resistor, RL, representing the load. Design steps. Choose the Zener diode. Select a Zener diode with a Zener voltage. Z. VZ equal to the desired output voltage. Example. For a 5V output, choose a Zener diode with. Determine the load current. Identify the current required by the load. Choose Zener current. Select a minimum Zener. To ensure the diode operates correctly in the breakdown region, choose a standard resistor value close to 280 ohms, such as 270 ohms or 300 ohms. Circuit diagram. 2. Overvoltage protection circuit. An overvoltage protection circuit safeguards sensitive components from voltage spikes. Components. Zener diode, VZ. Load device, e.g., microcontroller. Design steps. Choose the Zener diode. Select a Zener diode with VZ equal to the maximum safe voltage for the load device. Example. For a microcontroller with a maximum voltage of 5V, choose. Connect the Zener diode. Connect the Zener diode in parallel with the load device. When the input voltage exceeds 5V, the Zener diode conducts and clamps the voltage to 5V, protecting the load device. 3. Signal clipping circuit. A signal clipping circuit limits the voltage of an AC signal to prevent it from exceeding a specified range. Components. 2 Zener diodes, VZ. Design steps. Choose Zener diodes. Select Zener diodes with a Zener voltage. Z. VZ equal to the desired clipping level. Example. For clipping at plus or minus 5V, choose 2 Zener diodes with. Connect the Zener diodes. Connect the Zener diodes in series, but in opposite polarity across the signal source. When the signal voltage exceeds plus or minus 5V, the respective Zener diode conducts, clipping the signal to plus or minus 5V. Practical considerations. Power dissipation. Ensure the Zener diode's power dissipation does not exceed its rated value. Choose a diode with an appropriate power rating. Series resistor selection. Carefully select the series resistor to limit the current through the Zener diode. An incorrect resistor value can lead to inadequate voltage regulation or diode damage. Temperature effects. Consider the temperature coefficient of the Zener diode, especially in precision applications. Choose diodes with minimal temperature variation if stability is critical. Summary. Designing circuits with Zener diodes involves selecting the appropriate Zener voltage, calculating the necessary series resistance, and ensuring the diode operates within its specified current and power limits. By following these design steps and considering practical constraints, Zener diodes can effectively regulate voltage, protect against overvoltage, and clip signal waveforms in various electronic applications. Zener diodes come in various types, each designed for specific applications and performance characteristics. Here are the main types of Zener diodes. 1. Standard Zener diodes. Description. These are the most common type of Zener diodes used in general-purpose voltage regulation and protection applications. Characteristics. Available in a wide range of Zener voltages, typically from 2V to 200V. Moderate power dissipation ratings, typically up to 1W. Suitable for general voltage regulation and protection tasks. Applications. Voltage regulation and power supplies, overvoltage protection, and voltage reference circuits. 2. Precision Zener diodes. Description. These Zener diodes are designed for applications requiring precise and stable voltage regulation. Characteristics. Tighter tolerance on Zener voltage, as low as plus or minus 0.5%. Lower temperature coefficients, providing better stability over a range of temperatures. Often used in low noise and low drift applications. Applications. Precision voltage references and measurement equipment, ADCs, DACs, and other high-accuracy applications. 3. Surface mount Zener diodes. Description. These Zener diodes are packaged for surface mount technology, SMT, making them suitable for automated manufacturing processes. Characteristics. Available in small packages such as SOT, 23, SOD, 123, and others. Suitable for compact and high-density circuit designs. Wide range of Zener voltages and power ratings. Applications. Mobile devices, consumer electronics, and other applications requiring compact and efficient designs. 4. High-power Zener diodes. Description. These Zener diodes are designed to handle higher power dissipation, making them suitable for high-current applications. Characteristics. Higher power ratings, typically 5W to 50W or more. Larger physical size to accommodate better heat dissipation. Suitable for industrial and heavy-duty applications. Applications. Power supplies, industrial equipment, and high-power voltage regulation. 5. Temperature-compensated Zener diodes. Description. These Zener diodes have built-in temperature compensation to minimize the effects of temperature variations on the Zener voltage. Characteristics. Designed with specific temperature coefficients to counteract the natural temperature dependence of the Zener voltage. Provide a more stable reference voltage over a wide temperature range. Applications. Precision voltage references in environments with significant temperature variations, such as outdoor equipment and aerospace applications. 6. Low-noise Zener diodes. Description. These Zener diodes are optimized to produce low noise during operation, making them suitable for sensitive analog circuits. Characteristics. Reduced noise characteristics compared to standard Zener diodes. Often used in low-noise amplifier circuits and precision analog applications. Applications: low-noise voltage references in audio equipment, instrumentation, and communication systems. 7. Reverse-biased Zener diodes. Description: these are regular diodes operated in reverse bias mode at a voltage higher than the breakdown voltage, typically used in avalanche mode. Characteristics: higher Zener voltage range, typically above 5 V, where avalanche breakdown is dominant. Suitable for high voltage regulation and protection. Applications: high voltage power supplies and surge protection circuits. Summary: Zener diodes come in various types, each tailored to specific applications and performance requirements. Standard Zener diodes are used for general-purpose voltage regulation and protection, while precision Zener diodes are employed in applications demanding high accuracy and stability. Surface mount Zener diodes are ideal for compact and automated designs, and high-power Zener diodes are used in industrial applications requiring higher power dissipation. Temperature-compensated and low-noise Zener diodes provide enhanced performance in precision and noise-sensitive circuits. Understanding these types and their characteristics helps in selecting the appropriate Zener diode for any given application. Conclusion: Zener diodes are essential components in electronics, renowned for their ability to provide stable voltage regulation and protection across a wide range of applications. Their unique ability to conduct in the reverse breakdown region allows them to maintain a constant voltage, making them invaluable for various tasks. Here's a summary of the key points. Key functions: voltage regulation. Zener diodes are widely used to provide a stable output voltage in power supplies, ensuring that sensitive components receive a consistent voltage despite variations in input voltage or load conditions. Over-voltage protection. They safeguard electronic circuits from voltage spikes and surges by clamping the voltage to a safe level, protecting delicate components from damage. Signal clipping. In signal processing, Zener diodes are used to clip signals to specific voltage levels, preventing distortion and maintaining signal integrity. Voltage shifting and level shifting. They can shift voltage levels in logic circuits and other applications, facilitating compatibility between different voltage levels. Reference voltage. Zener diodes provide stable reference voltages for precision measurement and analog-to-digital conversion applications, ensuring accurate and reliable operation. Types of Zener diodes. Standard Zener diodes, for general-purpose voltage regulation and protection. Precision Zener diodes, for applications requiring high accuracy and stability. Surface mount Zener diodes, suitable for compact, automated manufacturing. High-power Zener diodes, designed for high current and heavy-duty applications. Temperature-compensated Zener diodes provide stable voltage across a wide temperature range. Low-noise Zener diodes, for noise-sensitive applications. Reverse-biased Zener diodes, operated in avalanche mode for high-voltage applications. Design considerations. Power dissipation. Ensure that the Zener diode operates within its power rating to avoid overheating and damage. Series resistor. Properly select the series resistor to limit the current through the Zener diode and achieve desired voltage regulation. Temperature effects. Consider the temperature coefficient of the Zener diode, especially for precision applications. Summary. Zener diodes are versatile and crucial for reliable electronic circuit design. By understanding their types, characteristics, and applications, you can effectively utilize Zener diodes in voltage regulation, protection, and signal processing tasks. Whether for simple power supply circuits or complex precision measurement systems, Zener diodes offer a robust solution for maintaining voltage stability and safeguarding electronic components.